So the topic of today is the National Petroleum Council Future Transportation Fuel Study. We're in the middle of the study, so I'm not prepared to discuss conclusions and findings, but part of our outreach is to discuss with interested parties what the scope, objectives, and the schedule of the study are so that we can get input, and that will help inform us as to things and conversations that are important for us to discuss as we move to our findings at the end of the year. This is an industry, national laboratory, and government study. We have many participants from industry, so we start every meeting with an antitrust guideline to remind us that coordinating company plans, policy, and outputs, or disclosing non-public information, or any process that might create competitive harm is not to happen at the study, and we're well monitored. We have attorneys that participate in our meetings and keep us clear on these antitrust guidelines. And this is a very important part of the activity that needs to be emphasized because of the nature of the participants. As I said, I'm going to review the Future Transportation Fuel Studies scope. The National Petroleum Council is not a trade organization. The purpose of the NPC is to solely represent the views of the oil and natural gas industries in advising, informing, and making recommendations to the Secretary of Energy with respect to matters relating to oil and natural gas. The NPC does not concern itself with trade practices, and it does not engage in any of the usual trade association activities, which means it advises the Secretary, and it does not lobby. And so it really is, as you'll see in this study, we are considering topics of interest. Secretary Chu issued a letter in September of 2009 requesting a study, a report on future transportation fuel prospects through 2050 for auto, truck, air, rail, and waterborne transport. So a very broad spectrum of transportation system. And we are to address fuel demand, supply, infrastructure, and technology in the context of protecting the environment, promoting economic growth and competitiveness, and ensuring energy security. So it is an extremely broad study. We are to describe accelerated technology pathways at the heart. We are a technology study. Pathways that will improve fuel efficiency, reduce environmental impact, and deployment of alternative fuels at scale, again, at commercial scale, by 2050. We are to deliver insights into potential policy options and investments that industry and government can take to accelerate the acceptance of alternative fuels, engines, and vehicles. There is a specific supplemental question. Again, our goal is to look at environment, economic, and energy security, but there was a specific challenge set forward to describe the actions that government and industry can take to achieve a 50% emission reduction by 2050 relative to 2005 standards. In putting together the teams at the outset, we had many guiding principles that had been passed on to us by other NPC studies. The most significance is the diversity of thought, and I will show you that we have a broad demographic of participants to promote consensus-based leadership. So we are not going to come up with a unanimous opinion, but minority opinions are discussed, they're treated with respect, and they will be discussed within the study so that we will give a balanced perspective. We'll also maximize the use of prior studies. At this point, we have considered almost 400 reports in our bibliography. So our foundation is other work, trying to understand what others have done before us, and then to move past that. Part of our activities are communication and encouraging outreach throughout the study. Like I said, this is part of that activity. And we are integrated with a second study that Secretary Chu also requested in parallel to this, which is the prudent development of North American natural gas and oil resources. So we complement that study. So while they're considering the development of our natural gas resources and oil resources in North America, and they're looking at what's going on in power generation within the grid, we really are looking at how do you use the energy in the transportation system. So we're complementary, and we integrate with them so that we're aligned and coordinated in our findings and our considerations. In the demographics, as I said, there's over 300 participants. If you look to the left, you'll see that we're well balanced. Only 25% is oil and gas. As I said, this is not dominated by oil and gas. We have also 23% transport manufacturers and 12% end users. So 60% of this study are industry participants, which makes us significantly different than a lot of other studies that you read, which you see, which are often dominated by national laboratory or academics. And that will give us a uniqueness in our insight. But we're also well balanced by government, federal, and state officials, NGOs, academia, and consultants, legal and financial experts. But as I said before, at the heart, we're a technology study. On the right, you see that we're 70% technology. We are considering how do you overcome technical barriers to accelerate these fuel vehicle supply chains. But we also have to consider policy and economics, and so we have a balance of policy and economics experts and a sprinkling of other interests. Our structure is at the top, the National Petroleum Council, of which there is a subgroup that was created within the council of the Committee for the Future Transportation Fuels, and then the Fuel Study Coordinating Subcommittee, of which I chair. Under that structure, we have demand, supply, and infrastructure, and technology task groups. But of the special note are the subgroups: biofuels, liquid hydrocarbons, natural gas, hydrogen, electric, and engines and vehicles, with supporting groups on emissions, report integration, data integration, and then we again align with our sister study on resource, North America resource development, so that we're coordinated. More details of the participants. It's chaired by Clarence Castlot, the CEO of Marathon Oil, my boss, Dan Poneman, who's the Deputy Secretary of Energy, Jim Owens, former CEO of Caterpillar, who chairs the Demand Task Group, John Watson, CEO of Chevron, who is championing supply and infrastructure, John Deutsch of MIT, the former Deputy Secretary of Defense and the former Director of the Central Intelligence, is championing the technology. And then Marshall Nichols, who's the NPC Director. And as you see here, the types of diversity of the participants, we have Westport Innovations, we have FedEx, we have NRDC, Resources for the Future, Caterpillar, we have Toyota, Department of Transportation, Deutsche Bank, Walmart, General Motors, Archer Daniel Midlands, just to name a few. We have over 300 participants, but these are a sampling of the leadership. Which you see on the next slide. Todd Werpy from Archer Daniel Midlands chairs the biofuel subgroup. Chris Erickson of ExxonMobil, the hydrocarbon liquid subgroup. We have Tony Buconfuso from the University of South Carolina chairing hydrogen subgroup. Bill Reinert of Toyota, the electric subgroup, and Mike Gallagher from Westport, the natural gas subgroup. Alan Taub for General Motors with the engine and vehicle subgroup. And we have Stephen Brand, former CTO of ConocoPhillips, dealing with our technical expert reviews. And so, again, broad base of input, which leads to some very lively conversations. The study is broken into two parts. Step one is looking at the individual fuel vehicle options. We're considering each fuel vehicle as an individual supply chain, unconstrained by competition of the other. So in step one, we've asked each group, what is the best and the fastest you can go to 2050 to produce a commercial product? And so these groups are just finishing up this evaluation. We started with a reference case, which is the Department of Energy EIA AEO as our reference case, which is well documented. It's something that any reader can go back and look in great detail as to the kinds of assumptions. It's a reference case. And then we bridge from that reference case and talk about the deltas. What kind of accelerations can we do? So that allows the reader to understand our starting point. And we describe fuel vehicle supply chain pathways and supporting infrastructure, the opportunities and the technology options to accelerate. We evaluate probabilities for success and develop supply curves, and then discuss what can be done to pursue these possibilities. Then we move into the integration phase, which is actually starting now, today. Our meeting has started this morning. We're now saying, now that we have this foundation, how does this competitive stew work. We already have vehicles in the marketplace. They don't develop independent of each other. There's competition. And how does that go? What happens when a first mover advantage happens in one of these supply chains? Does it prevent another supply chain from developing? What kind of breakthroughs are expected in the timing of those breakthroughs? Will they interfere with the development and the commercial development of these particular supply chains? And this is the second interesting feature of this study, is considering how one supply chain development impacts another supply chain development. There are many studies out there that talk about what do you do to get to electric vehicles? What do you do to get to natural gas vehicles? But you don't see many studies that really consider what happens when they're all developing and competing for the same funds, and they're competing for infrastructure, and they're trying to develop at the same time.